So a mirror has light reflecting off of it almost completely so that you can see very clearly all of the objects in the room. It's not 100% effective because there is still some light from the surrounding room that is scattered due to imperfections in the mirror surface, but it is one of the closest that we have to 100% reflecting of light, giving you a complete colorful image of the objects in the room around you. When light comes out of a fixture, especially when it's white light, it's composed of all the colors of the visible spectrum. When it hits an object, some of the light is absorbed, some of it is reflected. So in the case of this red shirt, all of the light except for the red light is absorbed by the shirt. The red light is reflected, which hits your eye, and that's why you see the shirt as red. In the case of this white shirt, all of the visible light is reflected off of the white shirt, causing your eye to see white, because white light is a combination of all the colors, so the color white that you see is a reflection of all of those colors. The color black, on the other hand, is an object that is absorbing all of the visible light, and your eye doesn't see anything, so it fills in the color black. Black is the absence of color when you're talking about the visible spectrum. You can't see ultraviolet, you can't see infrared, so even though the shirt might be reflecting ultraviolet or it might be reflecting infrared, it shows up to your eye as black because your eye is incapable of seeing those spectrum. Okay, so we've got a black car and a white car that are sitting right next to each other in the heat of the sun. And what I wanted to show you is the black car on the thermal imaging camera is absorbing a lot more energy. The hood of the car is showing up at about 104, 105 degrees. Whereas the white car that's right next to it, that's been sitting in the sun, is about 86 to 88. So it's about 20 degrees cooler than the black car. All right, so this is a device called a meter stick optical bench. That is a convex lens. What happens with a convex lens as light goes through it, the light, how am I going to do this with one hand? There we go, it is doing it. The light goes through the top and gets bent downward so that the image that you see on the board is an upside down image of the flame. So when you look through a telescope, you see an upside down image because it's bending the light. And if you look at this graphic, the light from the top of the candle goes into the lens bends down because as the light passes from the air into the glass, the material that the lens is made of, it bends, it slows down and changes direction, and then as it comes out of the lens, it again bends and this time speeds up as it goes through the air, and now it's coming out the bottom, so the top of the object is being shown at the bottom of the projected image. So if we come back to the meter stick optical bench, you can see the top of the candle is being shown at the bottom of the board. So this door is opaque. Light cannot get through the door. You cannot see what's on the other side of the door. If I go to the right, this window is transparent. Transparent means you can clearly see through it. Light comes through and allows you to see the full image on the other side. So you can actually see there's a chair 2 rooms away because you're looking through this piece of glass, you're looking through the piece of glass in that door across the hall, and you can see the chair all the way on the other side across the hallway. It's kind of a middle ground between the two. This milk jug is translucent. You can see light coming through it. If I were to shine a flashlight on the other side of it, you can see the light coming through, but you cannot clearly see images in definition. So see, you can see the Van de Graaff generator right there, but if I hold this in front, you can no longer see it. You can see the plant grow station right there, but if I hold this in front, you can no longer see it. However, especially with the plant grow station, if I turn off all the lights in the classroom, that is now the brightest thing in the room. You can see how some of the light is coming through the translucent milk jug, but you can't see the plants or any of the other defined images because not all of the light's coming through. All right.